All right, everybody, welcome back to another episode of our Algebra 1 virtual tutor. In this episode, we're going to look at Objective 30. And Objective 30 is going to be a bit of a longer one. What we're going to do is we're going to apply direct and inverse variation equations. Now, direct versus inverse is really the key here. This is going to be a fairly long process, but they're basically the same thing once you get what type of variation we're going to do. Now, before we even get to direct versus inverse, a variation is a relationship between variables. We've discussed this a little bit in the context of a scatter plot and a regression equation. But these are very specific types of variation. So our direct variation is found that if one quantity increases, the other increases. So as one value goes up, so does the other. Or as one goes down, so does the other. So either both values are going up, both values are going down. That's varying directly in its basic form. There is some other stuff going on, but it's going to start with that, just recognizing the difference. So the formula for direct variation is y equals k times x, which looks familiar because that's y equals mx. K is slope. We're calling it something different because we're in a different context, but it's still slope. Notice the most important thing here is what's not here. There is no y-intercept. That doesn't mean it doesn't have one. It means that it's plus 0 there, that y equals kx, mx plus b. Whoops. There's really a plus 0 here. And that's often the best way to figure out if something's a direct variation, because in addition to this 1-to-1 ratio where the slope's either going up or down, it has to start at the origin. And one of the most important aspects is that it starts at the origin. Now, inverse is simply what inverse means. It's flipped. So as one value goes up, the other value goes down, or vice versa. Now the formula is a little different. This one actually gets written two different ways. The first way will be like that, k divided by x. And there's your inverse because it's kind of flipped. But what a lot of people will do, and you'll see this on a lot of tests, is we'll actually take that x and kind of move it to the other side, multiply both sides by x. And that makes an equation that's a little easier to work with sometimes. Notice now, this still does not go through the origin, but it's no longer going to be a straight line. So we can easily see inverse variation because it'll have some sort of curve or something going on there. Okay. Our first job is to recognize whether something's direct or inverse. More times than not, the problem will tell us in one way or the other how to use it. So, what do these problems look like? Well, let's get our steps. You can see in example 1 here, they are word problems, and variation problems are word problems. So, our first step is to kind of digest what we're asking. And in number 1, 2 words. So I'm looking for the two variables that are related, the two variables that have relationship. All right, so Kim owns 5 shares of stock and receives 12 years in dividends. How many shares of stock would she need to earn? 24. So the only two things I see with numbers, she earns $12 and she wants to get that to 24. So you see how those variables are related because they're talking about the same thing, dividends. Now, the only other number I see is 5 shares of stock. Well, the problem's actually asking for you to find that, and I've set up my relationship now. Now, this we're going to make into a fraction. We're not going to use the variation equation much because it's direct variation. As one value goes up, so did the other. So this 12 is going to go to a 24, and I'm obviously going to need more stock here. I know this is direct. So rather than use y equals kx, which I could, I'm going to make this into a proportion. And what am I going to do? I'm going to do 5 over x equals 12 over 24. A direct variation is a proportion. So as long as I keep these the same thing, I keep them consistent, I can solve this by cross multiplying. Ooh. And 24 times 5 is 120. There we go. And I got 10. So I would need 10 shares of stock. Okay. Now, in number 2, you can see it's the same thing, though this is far less advanced. They tell me W varies directly with K. So that sets up my relationship and tells me that these are directly related. So they are directly proportional, which means, all right, here's my values for W, and here's for K. So I can do a proportion. I can do 5 over 2 equals 75 over W. Okay. Cross multiply that. And divide. And I'm going to get 30. So that's the first way to solve these problems, is that if they are directly proportional, just make a proportion. Now, here's the fun one. When it's inverse, we're still going to use a proportion. We haven't even gotten into our formulas for this yet because we're still using this idea that it's proportional. And we're going to do the same thing. Now, let's see. 5 workers in 24 days. So there's my 2 variables. And I want to bring that down to 15 days. So I have to figure out how many workers I'll need to do that. Think about what that's going to be. If I'm doing a project and it takes 5 of us 24 days to do this, if I want to bring the time down, if I want this value to come down, don't I need to add workers to that? So my number of workers needs to actually go up. And that's what inverse relationship means. That as one value is coming down, one is going up. So I'm going to set up my proportion. There's my workers. Like so. But because this is inverse, my next step before I cross multiply is to actually take one of them and make it the reciprocal. Or make it inverse flipping it. Now I can solve this identically the same way. Cross multiply it. and divide it. And you can see my number of workers did go up. So again, because we're dealing with relationships and proportions, we can solve all of these with proportions. Now, we're going to get into what those equations were a little bit, but I haven't used the actual definition of these yet. I've just used the idea behind them, that they are relationships. So 4 is going to be the same thing. Let's see. Find y. So my first proportion is 39 over y. And then when x is 3 and y is 11, I'm going to do 11 over 3. And notice I flipped that around. Now, when I cross multiply this, I actually don't get, well, it doesn't come out even. So, no, that's all set up good. It's all right. It's not a great problem, but that's okay. We'll just leave it as a fraction. Now, something occurs to me back here. Yeah, we got a problem here. I set this up as a variation, but I ignored that right there. I just said y varies directly with k and got 30. Notice that's not what this problem asked. It said y varies directly with k squared. So let's do 75 over w is not changed, but it's not k, it's k squared. So I need to be careful and see if this doesn't change my problem here. Likely will. Oops. Yeah, and what I get is 12. So I need to be careful. This would be w equals, well, that's going to be, well, I can't write today apparently. W varies directly with k. And this one is w varies directly with k squared. So be careful that we're actually answering the questions there. All right, now all of those can be solved with proportions. The rest of these, you're going to have to use the actual equations. So if I say just solve, find the value in something else, we've done that. We can do that with proportions. The rest of this, we're going to have to use our relationships and our variables, our equations to solve. So in this one, I see directly proportional. But when I look here, it says write an equation. So because it says write an equation, I don't want a proportion to solve. I want the equation. And the equation for direct variation is y equals kx. So they tell me that the calories burned while walking, d. So I'm going to change this right away to calories equals k times distance. Now, what do I want to do when I write the equation? I'm going to plug in my values, 180 times 2, and I can solve for this value here, which was my slope. we'll see in a second, this is actually called the constant of variation. The slope, the constant of variation. Slope, the change. Think about that, the change. So what's my equation that will model this? Well, we plug in the slope. And then we could use that equation to solve, though we don't have to because we have a proportion. Now, in number 2, they ask for the same thing. They do say varies directly. So they tell me that m varies directly with p. Let's plug in what we know. And when I solve, the constant of variation is 5 over 7, which in this case is all we're asking for, k. If I wanted to write the equation, it'd be m equals 5 over 7p. Okay, here, again, I'm asking for constant of variation. So I'm not actually asking for you to solve it the whole way. I'm simply asking for a part of the equation. So what do they tell me? The weight varies directly with its volume. So weight varies directly with volume. So let's plug in. And 28 divided by 20, whoops, I'm going to get 7 over 5. You would do the same thing if I said inverse. We would just start off with the inverse equation formula. Okay, and then last, again, this one though, I'm actually solving. So this one, I'm going to use a proportion. There's my bottles. And here's my temperature. So when I cross multiply, there's my answer. So notice when I'm actually trying to find an answer, I'm using a proportion. When I want one of the other pieces, I'm using like constant of variation or equation, I'm using the equations. Now, a couple of things that we haven't talked about here is recognizing that, and that's almost a big of a part. Now, we're not going to do any practice on that, but it's good to have that in kind of your, I don't know, toolbox, I guess. And that is to recognize that is a direct variation. Whereas this is not. Just understanding that oftentimes is enough to answer certain questions, because I'm going to give you a graph and say which one's a direct variation. We won't do it too much with inverse. Where we'll do it with inverse is I'm going to give you a table of values, and you have to determine, are both the values going up? Well, then it's direct. Are both the values going down? That's direct. Is one going up and one going down? That's inverse. Now, the most used question on here has to do with these graphs. And what it says, I'm going to give you a point right here, and I'm going to say plot 2 more points that form a direct variation. Well, think about what I just told you. what does one of the points have to be in order for this to be a direct variation? That point has to be 0, guys. Has to be, because that's definition of direct. Now, how can I find another point? We're going to use slope. So I'm going to find the slope that this is up 2 over 3. And I'm going to go up 2 over 3 more to find my other point. And that, by far, you will see for sure on any assessment we take, because it's plotting 2 more points. It's using this definition. It's using these definitions. Okay, that concludes our video for Objective 30. Again, feel free to go back and review as you please. We'll see you next time.